P1 plus 1/2 PV1 squared.
P1 plus 1/2 rho V1 squared. What does rho stand for, Will?
Density.
There you go. Plus
Rho G Y1.
and if you want to use H's for that, that's fine as well, but it's a height there, right? Equals?
Equals P2 plus 1/2 rho P2 plus rho G Y2.
Like this.
Right, very good. So basically then this tells us that when the speed of a fluid goes up, what happens to its pressure, Holly?
It goes down.
It goes down. Good. When the speed of a fluid goes up, the pressure goes down. Also, if the height of the fluid goes up, what happens to the pressure then, Timmy? It goes down. And so basically what happens then is whenever you gain either kinetic or gravitational potential energy for your fluid, the pressure goes down. Okay? Because essentially what happens is that some of that pressure is used to do work to gain that energy. It's really a conservation of energy equation. Okay? Guys, today for your lab, you're going to be looking at something called Toricelli's Law. You're going to have a big cylinder that's going to be open in the top, and it's going to have a little hole somewhere part way down. Okay? And in that cylinder, you're going to have some water. And so who can tell me what should be the pressure here on the top of the fluid? Kelly? Atmospheric pressure. Okay? And who can tell me what should be the pressure right there at the hole? What should be the pressure right there at the hole that is open to the atmosphere? Will?
The same.
Atmospheric pressure, okay? So P1 and P2 are both going to be atmospheric pressure. Does that make sense? Okay? Now, if I have a hole right here and I unplug the hole, what's going to happen? Chris?
The water's going to come out.
Water's going to come out, right? And in fact, it will shoot straight out the side, and it's actually like a horizontal projectile process. Okay? And who can tell me, what do you think determines the speed of that water coming out of the hole? What do you think is going to determine that, Michael?
The size of the hole.
Actually, no, it doesn't. It doesn't. If you ignore the viscosity of the fluid, it does not, and it's pretty negligible in this case. Chris? What pressure?
Atmosphere. On the top.
Pressure's the same in both places, so you think it's the pressure?
Cool.
Holly?
The depth at which the hole is.
Okay, compared to the top of the water. The higher I have water above the hole, the faster I would expect it to
Shoot out.
come out. Does that make sense? You'll see today if Holly's right. Does that make sense, though? All right, good. All right, so the pressure here and the pressure here are the same. Okay? We have a speed coming out of this hole. Now, if this is a very, very small hole, and this is a very, very large container, of course, over time, what's going to happen to this water level? It's going to decrease. Is it going to decrease very fast, though, if this is a very small hole in a very big container? No. And in fact, for this equation that you're going to learn called Toricelli's Law, we assume that the speed up here is so small that we can call it zero. Okay? So this V up here is approximately 0. Okay? And then we're going to have this distance from where this hole is to where this water level is. We're going to call that little h. And that little h is going to be equal to our y1. And so what are we going to call our y2? 0. And that's as much help as I'm going to give you deriving the equation. But that's what you're going to be doing today. Does that make sense? All right. So, I'll let you guys get up and I'll show you exactly how the lab works. Just keep it running, Jenna. Come on. You guys get up. Now guys, this lab is very difficult to do without making a mess. I think it has stopped raining, so we're actually going to go do the lab out on the patio. If it starts raining again, we'll come back in here and work up here, but it just tends to make a mess. So you're going to have a tube. Your tube has one open hole on it. The other two will be taped up for you. And what you're going to do, plug the hole with your finger, fill your tube up partway with water. And then if it starts raining and you have to actually do this inside, then you have to try to catch your stream of water in the pan, which is not easy to do. And that's why, like I said, if it's not raining, we'll just go do it on the patio. Okay? All right? But what you're going to do is you're going to measure what the lab calls big H, which is the height from your hole down to either the countertop in here or the concrete out there. Little h, which is the height from your hole up to the water level. And then the third thing you have to measure is actually how far the water shoots from here before it hits the ground. Okay? And so what you'll do is just quickly move your finger and plug it back in. Okay? And you have to just kind of take a finger and mark where that hit the ground, measure how far it goes. That make sense? Okay? And then what you're going to do is you have to do like 5 or 6 trials. You keep changing the height of the water and measuring the distance that it shoots. Does that make sense? Okay? And then you'll evaluate the lab from there. Does anybody have any questions? Everybody good? All right. Got lab sheets right here. Meter sticks I'll get down for you from up there, and we will get started. Thank you, Jim.